All right, let's do section 9.1, page 445, number 41, which reads, use the sandwich theorem to show that the sequence with the given nth term converges and find its limit. So for number 41, the sequence is an equal to sine n over n. Now we are told to use the sandwich theorem, so let's remember what that is. The sandwich theorem says that if I have two sequences that both converge to the same limit, and I have a third sequence that's greater than or equal to one of those sequences after some value of n, and that new sequence is less than or equal to another sequence after that same value of n, then if those two outside sequences both converge to the same limit, then that new sequence in the middle has to converge to the same limit too. So when you're applying the sandwich theorem, the really tricky part is figuring out what those two outside sequences are going to be. What are we going to sandwich an in between? And there aren't really any cut and dry rules for doing this. You have to really think about it, and you have to really notice things, and you have to pull forward into your head any scrap of information that you might have about the sequence that you're looking at. So we're looking at an here, which is equal to sine n over n. And you need to think about anything that you know about either pieces of that sequence, the sine n or the n. Well, we all know something about sine n, right? It's a trig function. And the thing about a trig function, especially sine and cosine, is they can only have extreme values of -1 and 1. So sine n has to be greater than or equal to -1, and it has to be less than or equal to 1. Well, this is a really important piece of information, because if I divide this whole expression by n, then I'm going to have -1 over n is less than or equal to sine n over n, which is going to be less than or equal to 1 over n. And this is the sequence that I'm trying to sandwich in between things. And I've sandwiched it in between -1 over n and +1 over n. Now, in order for the sandwich theorem to work, -1 over n and 1 over n have to converge to the same limit as n goes to infinity. So that's what we really need to check out now. So if I take the limit as n goes to infinity of -1 over n, what am I going to get? Well, remember, we have a series of methods that we use when we're evaluating a limit. We could make a graph, that's the first one. The second one is to substitute in. And what if I substitute in? What am I going to get? -1 over infinity, and what's that going to be equal to? 0. So I know that the sequence -1 over n is going to converge to 0. Now, what about my other sequence? I'm going to have to take the limit as n goes to infinity of 1 over n. Again, I can just substitute in here, and I'm going to have 1 over infinity, and that's also going to be 0. So both of these sequences go to 0. And I know that the sequence that I'm interested in, sine n over n, is greater than or equal to this sequence, really for all values of n, and it's less than or equal to this sequence, again, for all values of n. And this tells me that the limit as n goes to infinity of sine n over n has to be the same as the limit for this sequence and this sequence. So yes, this sequence sine n over n is going to converge, and its limit is going to be 0.